Okay, yo, LONCAPA 4. Let's do it. So this is a bit of a tricky question, just even understanding like how we're gonna go about it. So let's draw our free body diagrams first. We have a free body diagram of the cup with it has just a tension going up and its mass, so mass of the cup times gravity going down, right? And then we have our book, and this is where things get a bit tricky. So our book has gravity going down, but it has two components of gravity. It has this our theta, by the way, of the inclined plane, has mass of the book, gravity cosine theta, mass of the book, gravity sine theta. It also has our tension, so T, and our tension also has two components that I'll just write out in the, or actually here, I'll draw it out. So tension is our T, our theta, and we have our T sine theta, whoops, little brain fart, T cos theta. And then here, we also have the frictional force. So why do we have kinetic friction? It's because it's saying it's given a push up the slope and with a speed of whatever, of 2.24. So if it's already in movement, then it has a kinetic friction. You've already passed the static friction. It has a kinetic friction. But since it's moving upwards, our kinetic friction has to oppose motion, so it's going downward. Okay. We also here have a normal force. Okay. In this case, they say as well that upward is the positive direction. But when I'm solving, I'm going to solve the other way. I'm going to say downward is the positive direction. And why is that? It's because when it's moving upward with a speed and then released, we know that its acceleration is actually going to be downward because there's no more forces pushing it upward to surpass all the other forces pushing it downward. So it's slowing down. So we're trying to find that acceleration of how fast it's slowing down. So the cup here, we'll start with the cup, and we know that mcg minus t has to equal mca. So those are all of our forces in the F net, and has to equal mass times acceleration. Here's where it gets a bit tricky though. So we'll start with our y direction, because that's a more simple one. We have our normal force has to equal this component of gravity here. Why is that? It's not moving off the plane, so our F net 0. In the x direction though, we have three different forces. We have F of kinetic friction, we have the tension, and we have m plus m, we have the component of gravity that's going down the slope. Okay, sorry, I just realized I wasn't scrolled down enough. So there we go. We have our equations, which actually equals to m of the book times a. So we have our equations all set up. Now what do we have to do? We have to plug things into each other, basically. So we know that Fk is actually equal to just mu k times n. So we can plug in here that mu k n plus t plus mbg sine theta equals mba, mcg minus t equals mc. I'm just rewriting that so they're on the same line. Looks nicer. So we have equation 1 and equation 2. Okay? Thing is, though, that here we can also see that it's kind of just math from here. So I'll highlight everything we have. On the left side for equation 1, we have this mass, we have gravity, so we have both of those. We do not have tension, but we have the mass of c, and we don't have acceleration. In this case, actually I forgot to rewrite here, so we know what the normal force is as well. So it would actually be mu k mbg cos theta, and that comes from the y, that comes from this right here. That comes from that. So mbg cos theta plus t plus mbg sine theta equals mba. We know, in this equation, we know what mu k is. They gave us that. We know what mb is, we know what g is, and we know what cosine theta is. We also know all of that, and we know mb. So what are we left with? 2 equations and 2 unknowns. You can solve this by any method you really want, and you'll end up with your a. So your a is equal to whatever. Then for part 2 of this question, let's scroll back up. Part 2, it says, how far does the book slide before it comes to a stop? This is our simple kinematic equations. We would have a, we would have our velocity, initial velocity, which would be it's whatever's in your question. So we have our initial velocity, we have our a, we have our final velocity because it's 0, it came to a stop. We just want to find our distance, and you plug it in with the kinematic equations.